Good evening, everybody. Today we are going to discuss about source free RC circuit. Okay. We have this is a circuit diagram of source free RC circuit. Okay. Here we are going to see the fall of a capacitor voltage in this circuit. Okay. Here this is source free RC circuit. Okay. Initially, for t less than 0, the circuit would be like this. Okay. For t less than 0. Actually, in this circuit, the switch is in position 1 for a long time. Okay, t is equal to 0. It is moved to position 2. Okay, it is for t less than 0. This is in position 1, right? Okay, then if the switch is in position 1, what will be the circuit? The circuit would be like this. This will be the circuit for t less than 0. Okay, where Vs is the applied voltage. Okay, R is the resistance of this resistor. Okay, C is the capacitance of this capacitor. Right? Okay. Now this instant is t is equal to 0 instant. Okay, at t is equal to 0, which is thrown to position 2. It is thrown to position 2. Okay. At t is equal to 0, which is thrown to position 2 means for t greater than 0 also, it will be in position 2. Okay. Earlier, the switch was in position 1. Okay. Which is moved to position 2 at t is equal to 0. Means for t less than 0, switch was in position 1. Right? Okay. For t less than 0, this will be the circuit. If this instant is t is equal to 0, then what will be this instant? This instant is t is equal to 0 minus. What about this instant? This instant is t is equal to 0 plus. Okay. For t less than 0, at t is equal to 0 minus steady state occurs. Okay. At t is equal to 0 minus steady state occurs for t less than 0. Here steady state occurs. Okay. T is equal to 0 minus steady state occurs means under steady state DC voltage, capacitor acts as open circuit. Means capacitor is replaced by open circuit at t is equal to 0 minus. It means here at t is equal to 0 minus, final value occurs for t less than 0. For t greater than 0, steady state occurs when time approaches infinity. That is, when t is equal to infinity, steady state occurs. Okay. At steady state, under steady state DC voltage, capacitor acts as open circuit. Again here, capacitor will act as open circuit. The value at t is equal to 0 minus is Vc of 0 minus. The value at t is equal to 0 plus is Vc of 0 plus. Vc of 0 plus. Right? Okay. For t less than 0, this will be the final value. Okay. Whereas for t t greater than 0, VC of 0 plus is initial value. VC of 0 plus is initial value. Okay. Already you know the property of the capacitor. Voltage across the capacitor cannot change instantaneously. Means whatever the voltage is available at t is equal 0 minus, same voltage will be available at t is equal 0 plus. Okay. Voltage doesn't change instantaneously. Voltage across the capacitor cannot change instantaneously. Means whatever the voltage is available at t is equal 0 minus, same voltage will be available at t is equal 0 plus. Means VC of 0 minus is equal to VC of 0 plus. Finding this value is nothing but finding VC of 0 plus. Okay, this is nothing but initial value. Initial value for t greater than 0. This is final value for t less than 0. Okay. Final value for t less than 0 is equal to initial value for t greater than 0. Okay, both will be equal. Both will be equal because voltage across the capacitor cannot change instantaneously. Means within 0 time, voltage across the capacitor cannot change. Okay, whatever the voltage is available at t is equal 0 minus, same voltage will be available at t is equal 0 plus. So VC of 0 minus is equal VC of 0 plus. Okay, so here let VC of 0 minus is V naught. V naught here nothing but okay. At t is equal 0 minus, what will be the circuit? We have to find VC of 0 minus at t is equal 0 minus, right? Okay, at t is equal 0 minus, what will be the circuit? Circuit will be like this. Okay, this is Vs. Okay, R open circuit. Okay, voltage across this is VC of 0 minus. Voltage across this is VC of 0 minus. Here VC of 0 minus is what? Nothing but applied voltage, Vs only. Nothing but applied voltage. Okay, so here V naught is nothing but what? Vs. For t less than for t greater than 0, what will be the circuit? Okay, circuit would be like this. This will be the circuit. This will be the circuit for t greater than 0. Okay, already some energy is stored in this capacitor. Already some initial value is present in this capacitor. Okay, what is that initial value? VC of 0 is equal to V naught is equal to Vs. In this particular circuit, it is Vs. Okay, it could be any value depending upon the circuit. Okay. For this particular circuit, V naught is equal to Vs. Okay, now you apply KVL around this loop, then RC d VC of t by dt plus VC of t is equal to 0. You are going to have the equation right? Okay, this is not non-homogeneous differential equation. This is homogeneous first order differential equation. Homogeneous first order differential equation, right? Okay, so for this differential equation, the solution would be complete solution is nothing but complementary function only. Okay, which is nothing but transient response. Okay, which is equal to a1 e power alpha t. Okay, here force response is 0, steady state response is 0 because it is source free RC circuit. Now it is called source free RC circuit. Okay, for t greater than 0, the circuit is called source free RC circuit because no source is connected to the circuit. Okay, that's why it is called source free RC circuit. Okay, source free RC circuit. For source free RC circuit, this will be the solution. Only you're going to have transient response. Okay, steady state response becomes zero. Steady state response becomes zero. Okay, so here complete solution is equal to A1 into e power alpha t. Okay, finding alpha. Okay, finding alpha, you take this equation. Okay, by considering that equation, RC alpha is differential operator, d by dt is nothing but alpha. Okay, plus 1 into Vc is equal to 0. From this, alpha is equal to minus 1 by RC. Minus 1 by RC. Right? Okay. Then you're going to have the equation like this. Vc of t is equal to A1 e power minus T by RC. T by RC. You know, to find A1, let us use initial condition. Initial condition means at t is equal to 0. At t is equal to 0, Vc of 0, okay, it is written right. Vc of 0 is equal to Vs is equal to Vc of 0 is yes. Sorry, circuit is equal to A1 e power minus 1 by RC into C. Sorry, minus 1 by RC into 0. Okay, which is equal to this implies A1 is equal to Vs. A1 is equal to Vs. Okay. Finally, you're going to have the expression like this. Okay. Vc is equal to Vs into e power minus T by RC. Okay. So we have the circuit like this, right? This is the circuit, right? Okay. Vc is the voltage across this. Okay. Current is flowing like this. Okay. Voltage at this point, with this point is what? VR. VR, right? Okay. So VR is equal to minus Vc of t. This is equal to minus Vc e power minus T by RC. Okay. I of t is equal to VR by R minus Vs by R e power minus T by RC. Here, time constant tau is equal to RC. Time constant tau is equal to RC, which is nothing but RTh into C. RTh into C. Okay. How can you define time constant? Okay. We are going to have the current waveform. Okay. Sorry, voltage. Voltage is equal to Vs into e power minus T by RC, right? Here, Vc of t. Let me draw the graph for Vc of t versus time. Okay. With respect to time, what will be Vc of t? Initially, the voltage across capacitor is Vs. Okay, this is the expression for Vc of t. Okay, then exponentially decreasing like this. Finally reaches 0 when time approaches infinity. Okay, we draw tangent. Okay, this will be time constant tau. Okay, if t is equal to tau, the voltage would be 0.368 Vs. 0.368 Vs. Okay, here we have expression, right? Vc of t is equal to Vs e power minus T by RT. Okay, at t is equal to tau, the which is nothing but RC. This is nothing but RC. Okay. Then VC of tau, V of tau, VC of tau is equal to Vs into e power minus tau by RC. Okay, that is e power minus 1, which is nothing but 0.368 Vs. Okay. So here you can define time constant like this. It is the time taken by the response. Here the response is voltage across the capacitor. It is the time taken by the response to reach 36.8% of its initial value. 36.8% of its initial value. Okay. Here, this means that at time t is equal to tau, the voltage, the capacitor's voltage Vc drops to 36.8% of its initial value. Okay, so we can define time constant like this. It is the time taken by the response. Here the response is Vc of t, voltage across the capacitor. It is the time taken by the response to reach 36.8% of its initial value. Right, you're going to have the graph like this. Okay, so this is what Vs e power minus t by RC. Okay, this is minus Vs e power minus t by RC. Okay. Find the time constant for the RC circuit. Okay, finding time constant. Here, what is time constant? Time constant tau is equal to RC, right? Which is nothing but what? RTH into C. Here, RTH is Thevenin's resistance between the terminals of the capacitor. Okay, so how can you find RTH? By making all sources 0. Okay, making all sources 0 means this source is replaced by short circuit. Voltage source is replaced by short circuit. This is 120 ohm. This is 80. Okay, this is 12. Okay. Between the terminals of the capacitor, you find RTH. Okay. After finding RTH, here what will be RTH? ohms and 80 ohms. These two resistors are connected in parallel. Okay, so the parallel equivalent would be 120 into 80 by 120 plus 80, 48. Okay, 48 resistance. This parallel equivalent is 48 resistance. This parallel combination is connected in series with 12 ohms, means plus 12. Okay, 60 ohms. Okay, 60 ohms. Okay, so RTH is 60 ohm. What about C? C is 50 millifarads. Okay, which is equal to 3 seconds. Coming to the next question. The switch in figure has been in position A for a long time. Here finally we got the expression like this, right? What is the expression? Vc is equal to Vc of t is equal to Vs into e power minus t by RC. Okay, generally we are going to have the expression like this. See here, you know, right? Vc of t is equal to what is the expression? A1 e power minus t by RC, right? T by RC. Let us use initial condition. Vc of 0 is equal to A1 e power minus 0 by RC. Okay, so A1 is equal to what? A1 is equal to Vc of 0. Okay, otherwise We can say it is V naught. We can say V naught. Okay, so finally the expression would be, generally the general expression would be like this: Vc of t is equal to Vc of 0 e power minus t by tau, t by tau. Otherwise, you can also write like this: V naught e power minus t by tau. Okay, this is the expression for voltage across capacitor in case of source free RC circuit. Source free RC circuit. Okay, so here there is a given question. The switch in figure has been in position A for a long time. Assume the switch moves instantaneously from A to B at t is equal to 0. Find V for t greater than 0. Means switch is moved to position B at t is equal to 0. This instant is t is equal to 0. Okay, switch is moved to position B. Position B at t is equal to 0. Okay, it was in position A for t less than 0. T less than 0. For t less than 0, it was in position A. For t greater than 0, it will be in position B. It will be in position B only, right? Okay. This instant is t is equal to 0 minus. This instant is t is equal to 0 plus. Okay. For t less than 0, when time approaches infinity, steady state occurs. Steady state occurs. Under steady state DC voltage, capacitor acts as open circuit. Okay. For t less than 0, steady state occurs at t is equal to 0 minus. Under steady state DC voltage, capacitor acts as open circuit. Capacitor acts as open circuit. Okay, so voltage across capacitor cannot change instantaneously. You know, right? You know the property of the capacitor, that is voltage across capacitor cannot change instantaneously. Means Vc of 0 minus is equal to Vc of 0 plus. Okay. So we have to find initial value. Initial value for t greater than 0. Final value for t less than 0. Okay, so let us find initial value. Vc of 0 minus. So at t is equal to 0 minus, what will be the circuit? Voltage source 40 volts. Okay. 5 kilo ohms. It is in position A, right? Okay. This will be the circuit. Sorry. Under steady state DC current, under steady state DC voltage, capacitor acts as open circuit. Means capacitor terminals are replaced by open circuit. Now this will be voltage between these 2 points is Vc of 0 minus. Vc of 0 minus. Okay, what will be Vc of 0 minus? Which is nothing but 40 volts only. 40 volts only. Okay, as it is open circuit, no current flows to this circuit, right? So Vc of 0 minus is equal to 40 volts. Okay, we have general expression Vc of t. Vc of t is equal to, okay, for t greater than 0, what will be the circuit? Okay, for t greater than 0, what will be the circuit? Circuit becomes like this. This will be the circuit for t greater than 0, right? This is source free RC circuit. Means what will be the expression for voltage across capacitor? Vc of t is equal to what? Vc of t is equal to Vc of 0 into e power minus t by RC. E power minus t by RC. Right? Here Vc of 0 minus is equal to 40 volts. Nothing but Vc of 0 plus is equal to 40 volts. Because Vc of 0 minus is equal to Vc of 0 plus, because voltage across the capacitor cannot change instantaneously. Okay, so here we have to find time constant, which of 0 is equal to 40 volts, right? Time constant tau is equal to RC, which is equal to 2 kilo ohms into 10 microfarads, 10 to 10 power minus 6. Okay. Then final expression would be 40 into e power minus t by 20 into 10 to the power of minus 3, okay, which is nothing but 40 into e power minus 50t. This is the answer, right? So coming to this question, the question itself, it says that switch is opened at t is equal to 0. Switch is open at t is equal to 0. Okay, so this instant is t is equal to 0 instant. This is for t less than 0. This is for t greater than 0. Right? Which is opened at t is equal to 0. Means it will be opened for t greater than 0. Switch was in closed position for t less than 0. Right? You have to find voltage at t is equal to 0 minus. This instant is t is equal to 0 plus. Okay, in order to find initial value, you have to find the voltage at t is equal to 0 minus. At t is equal to 0 minus, steady state occurs. Steady state occurs. Under steady state DC voltage, capacitor acts as open circuit. Then at t is equal to 0 minus, what will be the circuit? Circuit becomes like this. 60 volts. Open circuit. At t is equal to 0 minus, steady state occurs. Under steady state DC voltage, capacitor acts as open circuit. VC of 0 minus. By using voltage division rule, 60 into 2 kilo ohms by 10 plus 2, 12. Okay, it is 10 volts. 10 volts. Okay. So t greater than 0, what will be the circuit? Switch is open, right? Switch is open means you're going to have the circuit like this. Okay. Tau would be RC. RT into same as previous problem. Okay, you can find VC of t is equal to V of 0 into e power minus t by 10. Same as previous problem. Coming to this problem. So the network shown in figure, find V of t for t greater than 0. V of t for t greater than 0. Right? Here, yeah, have to find V of t, right? I'll draw. This instant is t is equal to 0. This instant is t is equal to 0 minus. This instant is t is equal to 0 plus. Okay, which is opened at t is equal to 0. So t is equal to 0 minus is the instant where just before the switch is opened. T is equal to 0 plus instant is the instant where just after the switch is opened. Okay, you are opening the switch at t is equal to 0 means the switch has been closed for a long time. the switch has been closed for a long time. Means for t less than 0, switch has been closed for a long time. Okay. For t greater than 0, switch will be opened. Okay. Here steady state occurs. T is equal to 0 minus steady state occurs for t less than 0. Under steady state DC current, inductor acts as short circuit. Inductor acts as short circuit. Okay. For t greater than 0, when time approaches infinity, steady state occurs. Under steady state DC current, inductor acts as short circuit. Inductor acts as short. Okay. Now let us find initial value. Means a t is equal to 0 minus. Okay. A t is equal to 0 minus. What will be the current? What will be the current? What will be the first? What will be the circuit? Circuit will be like this. Two amps, 12 ohms, 20 ohms, 6 ohms, 6 ohms. Inductor acts as short circuit. Plus 20. 5. Okay, we have to find I of 0 minus the current which is going to the inductor. Inductor at t is equal to 0 minus, inductor is acting as short circuit. So I of 0 minus, we have to find the current which is going to 6 ohm resistor. Nothing but current flowing to the inductor at t is equal to 0 minus. As inductor is acting as short circuit at t is equal to 0 minus. Okay, let us use node analysis. Apply KCL at this node. Okay, if I apply KCL at that node, minus 2 plus V by 12 plus V by 20 plus V by 6 plus V minus 20 by 5 is equal to 0. Is equal to 0. Okay, then V into is equal to 20 by 5 means 4. 4 plus 6. Okay. What is value? Let me use calcium. 1 by 12 plus 1 by 20 plus 1 by 6 plus 1 by 5. Okay. 1 by 2. 1 by 2. Okay, so V is equal to 12. 12 volts. Then what will be I of 0 minus? I of 0 minus is equal to V by 6, which is equal to 12 by 6, which is equal to how much is it? 2 amps. 2 amps. So I of 0 minus is equal to 2 amps. Okay. You know, current to the inductor cannot change instantaneously. Then I of 0 minus is equal to I of 0 plus 0 plus, which is equal to I of 0 which is equal to 2 amps. Initial value is 2 amps. Okay. For t greater than 0, what will be the circuit? Okay, circuit will be like this. It is open, right? .5 Henry, 6 ohms, 20 ohms. Yeah, 20 volts. 20 volts, 5 ohms. 20 ohms. This is the circuit for t greater than 0. Let us find time constant. Tau. Tau is equal to what? L by RTH. L by R, not L by RTH. Okay, we have to find RTH. Here RTH is the resistance between the terminals of the inductor. Okay, Thevenin's resistance between the terminals of the inductor. Okay, so finding RTH between the terminals of the inductor, this is 20 ohms, 6 ohms. We have to find the resistance between the terminals of the inductor, RTH. Okay, here we have one more resistance, that is 5 ohm resistance. 5 ohm resistance. Okay, then RTH is equal to, here RTH is equal to, how much is it? Equal to 20 ohm resistance is in parallel with 5 ohm resistance. Then 20 into 5 by 20 plus 5. We're going to have 4. Okay, 4 ohm resistance. 4 ohm resistance is connected in series with 6 ohm resistance. Then RTH is equal to 10 ohm resistance. 10 ohm. Okay, then tau is equal to L by R. L is equal to 0.5. 0.5 by 10. We're going to have 0.5 by 10. Okay, you can see it is 1 by 20. 1 by 20 seconds. Okay, 1 by 20 seconds. Okay, we have the expression for current. I of t is equal to what? I of t is equal to I of infinity plus I of 0 minus I of infinity into e power minus t by tau for t greater than 0. Right? Okay, so we have to find I of infinity. So at t is equal to infinity, what will be the circuit? At t is equal to infinity, what will be the circuit? The circuit would be like this. Inductor acts as short circuit. At t is equal to infinity. Okay, the current which is going to this inductor is I of infinity. Okay, so this is 5 ohms. 20 volts, 5 ohms, 6 ohms, how much is it? 20. Apply KCL at this node. Okay, V1 by 20 plus V1 by 6. Sorry, V1 by 6, right? 6 plus V1 minus 20 by 5, which is equal to 0. From this, you're going to get V1 as, okay, V1 is equal to how much is it? The value would be, let me use calculation. 1 by 20 plus 1 by 6 plus 1 by 5. I think. It is 5 by 12. Means V1 is equal to 4 into 12 by 5. 4 into 12 by 5. 4 into 12 by 5. 48 by 5. This value is 48 by 5. Okay. What about I of infinity? I of infinity is equal to V1 by 6, okay, which is equal to 48 by 5 by 6. We're going to have 8 by 6. Sorry, 8 by 5. Okay, 8 by 5. 8 by 5 amps. Okay, you substitute all values in this expression. We're going to have I of t is equal to 8 by 5 plus 2. 2 is the initial value, right? 2 minus 8 by 5. 8 by 5 into e power minus t by 1 by 20 means minus 20t. Okay, here you are asked to find voltage across inductor. Okay, V is equal to LdI by dt. Okay, which is equal to 8 by 5. So plus what is value? 2 minus 8 by 5. Okay, this is 2 by 5. Okay, 8 by 5 plus 2 by 5 into e power minus 20t. Voltage across inductor is what? VL is equal to what? LdI by dt. LdI by dt. Okay, what is the value of L? L is equal to 0.5 means 1 by 2 into differentiation of this current. Differentiate this current. Okay, differentiation of this current. Differentiation of this constant is 0. 0 plus, okay, 2 by 5 into minus 20 into e power minus 20t, right? Then we're going to get 0.5 into e power minus 20t. It is given minus 4. You check once again. You check. If there is any calculation mistake, you please correct.
Sir, you got minus 4 only, sir. Minus 4 only, sir. Last step, 5 ones, 5 fours, 2 gets cancelled.
Okay, sorry. Yeah, it is minus 4. Sorry. Yeah, minus 4. Yeah, minus 4 e power minus 20t. Correct. Thank you. Likewise, we can solve remaining problems.